Welcome to the study guide video for Principles of Programs Chapter 9, Advanced Modularization Techniques. As projects grow in size and scope, managing the codebase becomes paramount to ensure efficiency and reliability. This is where modular programming comes into play, offering a structured approach to handle complexity. It emphasizes breaking down a program into smaller, independent modules, each with a specific responsibility. Modular programming promotes code reusability, maintainability, and scalability, which are crucial for long-term project success. Each module encapsulates specific functionality, making the codebase easier to understand, modify, and extend over time. By dividing a large problem into smaller, manageable units, developers can focus on one aspect at a time, reducing cognitive load. This approach improves readability and makes it easier to test, debug, and maintain the software. It fosters collaboration, as different teams can work on separate modules concurrently, enhancing productivity and innovation. Please hit the like button, leave a comment, and subscribe to the channel. At the heart of modular programming lie modules and APIs. Modules serve as the building blocks, each encapsulating specific functionality. They act like black boxes, hiding internal complexities. APIs serve as communication channels between these modules. They define rules for interaction, like a restaurant menu listing available dishes. A program cannot call one method at most. A method cannot contain other methods. A program can contain a method that calls another method. Every method has a header. A local variable is in scope in the method in which it is declared. An argument is a value in a method call. A program can call any number of methods. A method's interface includes its return type, identifier, and parameter list. Modular programming significantly enhances the software development lifecycle by breaking down tasks into manageable pieces. It greatly improves code readability and understandability, making it easier for developers to work with. By decomposing a complex system into smaller, more manageable modules, the codebase becomes significantly easier to navigate and understand. A method declaration requires a local name for any parameter. When you use a variable name in a method call, it can have the same name as the variable in the method header. Developers can easily locate and modify relevant modules without affecting others, ensuring stability and efficiency. Modular programming also promotes code reusability, which saves significant development time and effort by allowing the reuse of existing modules. It allows for isolated testing of individual modules, ensuring each component functions correctly before integration. Assume that you have written a method with the header void, my method, num_a string b, my method, 12, hello. The call to the method must contain a numeric value and a string value in that order. While modular programming is powerful, it has potential drawbacks that developers need to be aware of. Increased complexity can arise as the number of modules grows, making the codebase harder to manage. Managing many modules requires careful planning to avoid dependency issues and ensure smooth integration. Assume that you have written a method with the header num your method, string name, num code. The method's type is num. Performance overhead is another concern that cannot be ignored, as communication between modules can introduce latency and affect overall system efficiency. Assume that you have written a method with the header string my method, num score, string grade. Also assume that you have declared a numeric variable named test. The correct method is my method test a. The method call must include a numeric value and a string value in that order. The value used in a method's return statement must match the data type used before the method name in the header. When a method receives a copy of the value passed, the variable is passed by value. A void method returns nothing. When an array is passed to a method, it is passed by reference, meaning the method receives the array's address. Overloaded methods have the same name but different parameters lists. Each module performs a specific function, such as text formatting or managing plugins. A method with parameters string and num can coexist with another method that has parameters num and string. Methods in the same program with identical names and identical parameter lists are ambiguous. Methods in different programs with identical names and identical parameter lists are fine. They are neither overloaded nor illegal. Implementation hiding is related to the notion that a calling method does not know the details of the instructions in a called method. Programmers should strive to increase cohesion. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Modular programming will remain a key strategy, driving innovation and excellence in software engineering.